Sorry, I I had to step out. My dog wanted to get in the house, so. How are you doing? We'll start in a minute. (17C) midterm. You have Dr. Lair? I see. Yeah, it's more of an advanced course, so there's certain expectation with that course. Yeah, I think we offer it at MBC this semester, and I think Mr. Lee is teaching it, small section. So what we'll start with is, before we go in with the lab, we want to talk about the project. So let me get into screen share. I had to make some adjustment. Because we're using different things this semester. So I'll go over some of this again on Tuesday, just a summary version of it anyway. So it kind of give you a little bit of a head start today to think about what you want to do. I know we haven't covered cryptography, and also, we're just finishing graphs. So there will be one project option that's going to be cryptography. Okay, so let me share screen real quick. As you look at Canvas, you scroll down onto the bottom. I posted 2 out of the 3 parts. I have to make some adjustment in the part 3, and then I'll share with you some example down the line. So if you look at this module, the first page mainly, it just talks about what we're going to be doing. I'm not using GitHub too much this semester. I can go over how to use GitHub as we're proceeding through the project. Yep, I just got dropped off Zoom, sorry. So as we were looking at the project, what you can do is you can take a look at the components of the project. So I wanted to run through that quickly so you can think about it this weekend, and then we can proceed to it in the upcoming week. So the project criteria, this is all for part 2 really, is to have the options for you to select the project of your choice. You only need to do 1 case per team. So when you select your option, you need to make sure that you all agree if you decided to join a team. I don't want very large teams, so the maximum I'll have is maybe 3 person per team. At most 4, but I don't like the idea of having a very large team and people are not contributing, as this project is not too complex. Okay, so I'll do a quick run through, kind of give you an idea of what it should be looking like. Okay, so you will pick one option, whether you're doing it by yourself or you're doing it with the team. Now, the first case is going to be graph oriented. So we just started finishing graph now. This is going to be a case that's very similar to travel salesman case that you would see on the internet. Example of it would be the travel salesman case. So we have a solar company and the marketing specialists need to go from one city to the next to advertise. As you see, each of the edge is weighted, okay? So it tells you the number of miles from one city to the next. What we need to do with this one is we need to assume that if he starts from Riverside and return home daily, we wanted to come up with different routes for him to be able to possibly save time and gas. So we wanted to determine the shortest path and the low cost trips based on the given map. Then you have to produce a C++ program that would represent the trips, right? Your recommendations on low cost and shortest path. And you also need to include the matrices and the adjacency, which is what we're going to be seeing today. Okay. And in your documentation, you need to explain your solutions and your programming approach. So that way I can assess it and see that you're applying the concept. Okay. So that will be the first option. Now, in the past, over the course of 7 semesters or more that I've taught this class, the project has improved tremendously. So what I can do is later on, I can share with you some example of what the student had done so you can have an idea, but I want you to be able to come up with your own program and be able to plan your own program. So option 1 is using graph. Option 2 is using probability. So UCR Medical Center, they actually do volunteering program for people to travel before COVID-19 to different countries to help. And in the past, I've used 70 countries, but this time I'm going to use only 20 countries. So what we want to do is we want to write a program that's gonna match the physician to the country based on the language of their choice. So if I'm fluent in English, I wanted to be able to travel to the country that has a lot of the patients that speak English. If I'm fluent in Spanish, I can select the countries from the list to be able to give me the match. So the intent of this is to look at how you would handle the probability based on the language of the participant selection. Now, you need to have at least 5 languages and 20 countries implemented. It doesn't matter what country you wanted to add to the list, but you need to be thoughtful about the country that would be able to match with specific language. So for example, if I choose Spanish, you can include some South American country, some North American country, and some European country like Spain. If I choose English, I can travel to North American country like Canada, United States, also the European countries, and some other countries that also speak English, because some Asian countries and some African countries actually have English speakers. So you have to be thoughtful about how you would formulate the list or your arrays that would contain this. And when you write your program, you also need to implement their specialization. And you can come up, you can decide on what type of specialization they would be. So for example, if I am for pediatrics, then I can also make that selection. So that will be another array or another dimension that you want to include in your array. So the whole point is to allow the participants to match based on the language that they're fluent in. And statistically, UCR had mentioned in one of their article that it's about 20% of their physicians speak the fluent language of the country that they send them to. So we want to determine the probability of, based on the given information. Okay, so this one, you would implement the probability. This choice was not too popular across multiple semester, but I did have some students that turn in wonderful program for this case. Okay, so that will be part of the example as well. The third case is on Vigineer, and if you wanted to kind of see, you can research this a little bit, but we will cover Vigineer in about a week or so. A couple of weeks, within the next couple of weeks, I'll talk about the 2-dimension shift with Vigineer ciphering. So just to write a program that's going to ask the user to input a phrase that they want to encrypt, a key to use with that phrase. It will produce the encryption in text, and then it also asks for the decryption. So the whole point in writing a program to decrypt and to encrypt is that if we can decrypt. So I will touch on this theory in the next few weeks, and so this kind of give you the overall. So if you wanted to read through it, it talks about it, but we'll practice more on it. So the program will prompt the user the message that they want to encrypt and the key. And then I want you to test it, and you need to document how you approach the program. Okay, so that's case 3. On case 4, we're going to do a casino blackjack, and this is more of a program that would be like a card guessing program. So we wanted to implement the probability based on one deck of cards. I added some of the rules, the casino rules, for you to see if you fully want to implement it, so you can understand how the casino treats blackjack and apply the rules. Okay, like soft hands, double down. So when you write your program, you want to include these options. If they wanted to split their cards, if they want to wager more, when they wanted to double down on a certain hand, if they have a higher probability of winning. So in the blackjack program, as I give you the statistic here, even with based on the statistic, we would see that usually with the single deck, it's going to be approximately 0.17%. That's going to be the house advantage, and it tells you, if you have more decks, that would be different. Now for our program, we're only going to use a single deck, which is a 52 card deck. And with that, what we can do is we can show the cards that the dealer have and the cards that the player have, and we can determine the probability based on that. Okay. So for the case 4, the blackjack game, you are to write a C++ program using a single card deck of 52 cards. And we want to display the player probability for each hand. So if I'm getting 2 cards, let's say a face card like a jack and a 2, what's my probability of hitting a card that's going to get me the pot, right? So our goal is to get 21. So what's left in the deck that's going to give me a total of 21? So I have to hit a 9, and there's 4 9 left in the deck if the dealer didn't get the 9. So what you have to do is, and this one is, you have to think about how you would set up the arrays to represent the cards. And once it pulled the cards, right, what's left is going to be your probability for winning. So as they hit the cards, if I get one more hit, what's my probability of winning with the current hit, right? So before the hit and after the hit of the card. So that's what I wanted to see. So this one also tie back to probability. And I want you to explain that in the documentation on how you approach the program. So a part of this class, the ultimate goal is to allow you to think about the algorithm that you can implement for cases that would be for business use, institutional use, etc., to solve the problem. So we need to, work in the scope of that. And yes, there would be more cases that I can implement, but I wanted to make sure sorry, I got drop off again. Just my neighborhood between 5 and 7. It's a little spotty with the internet. Okay. So think about the option that if you decided to the option that you select. Okay. Now, so once you have, let me go into screen share. Once you have selected your option, I'm going to turn off my video real quick, but you can see my screen. Then what you want to do is you want to access this sign up form to get the 20 points. Whether you're doing it by yourself or you're doing with another person or 2 or 3, what you want is you want to sign up here, and this is going to take you to the course project sign up. Okay. So I want you to fill out your information. This is my way of tracking the teams. And my plan for this is to introduce you to various tools that you can use for your team, such as Microsoft Team on how you would be able to manage your resources and share your resources when you're working with other people. I did look at some Canvas enabled tools. It's not really designed for our type of work, especially with programming. So dropping files in it can be challenging. So I looked at Pisces and Canvas itself. So what I want to do is I want to be able to introduce you to something that you already have as a license. So I need for each one of you to complete this. Okay. And so that way I can help you set up your team or show you how to do that, and you can communicate directly with your team members. Okay. Now, if you decided to work by yourself, that's fine. You need to fill this out and you need to tell me which option you're going to choose. Okay. And this is my way of helping you manage your project so that way I can keep you on track. Also, if you're by yourself and you're thinking about maybe, I can help you look for a team, then there's a question in here. It asks you, do you want to join a team? And if you select yes, but you don't have one, then I can find people for you to work with. Okay. As I understand that working, remotely can be a little bit more challenging than actually, seeing people in the classroom. And I would have this to hold people accountable, and part of your project grade will be weighted with the team contribution if you are in a team. Now, if you are not in the team, like I mentioned, when you look at the scope of the project, that can be very, very lengthy, right? Especially if you're busy and you're working. So what you can do is, if you work with other people, you can divvy up the job, you can communicate back and forth. And in the real world environment, you would see that in development, we don't work by ourselves. We work with other people. In businesses and in every environment, we work with other people. So complete this once you decide on the options. And if you do have somebody that you want to work with or people you want to work with, if not, complete it and I can help you find the team or, help you manage your project. Okay. And then I will post a part 3 next week, as I need to edit some of it and I can show you how you can use your, I'm going to use Google Site. So ePortfolio option on Google Site. If you don't have a portfolio yet, you can start that and then you can add your project in there, so that way you can use it to link it with your LinkedIn or other profiles, so you can have the employers look at your project, because that's what they're really looking at right now, is for you to be able to work with other people and some kind of sample program that they wanted to see. Okay. And, I'm not looking for a lot of the technical things, but I want working programs. I've had students that turn in non-working programs because they ran out of time. I will try to give you some partial credit, but you can't expect, very much credit, as realistically, if you turn that into work, most likely that's not gonna hold. So we want that. This is why we want to make sure that we have enough time. Okay. Any question? Okay, so as we talked about the project, I'll come back to this topic in the next few weeks. And so my plan is to cover the last few units. We have a couple more to cover, and then I'll do final review while, you have project to work on. So we're not going to have too many labs in the upcoming week, so you will have time to work on this. And if you like, I will still hold Zoom sessions so you can still communicate with your group. And or if you wanted to set up something on the side, that's going to be your option. Okay. All right, so let's talk about the lab for today. We only have 3 things to do, and I copy and paste the code for you, but I wanted to go over it and explain it to you so you can understand it, as some of you haven't taken data structure. Okay, so we're gonna hit lab 10 right now. And I made some revision to it, so it's a little better. So I'll open my version of it, which is, it just contains some of the answers. Okay, so here is a simple graph to start. Okay, and we're mainly working with 2-dimension graphs. So in this picture, what you can see is we have vertices from 0 through 4. Okay, 0, 1, 2, 3, 4. And those can be treated as node, system, whatever, right? So what we want to do in number 1 is we want to start out with listing the vertices. Okay, so when you approach your project, you wanted to say, okay, what are the vertices that I'm working with given that graph? So for 1A, what we want to do is we want to start with listing our vertices, like what we've been doing with the assignment. So I have here my V, I would include 0, 1, 2, 3, 4. And transition this into the programming aspect. We can say, okay, well, we have to create a container that's gonna have these vertices, right? And so that way we can iterate through this container like an array or a vector in order to access each of the vertex, and we can say who is adjacent to who. Okay, so looking at this picture, we have 0, 1, 2, 3, 4 vertices. Then next is we would list the edges. The reason why we wanted to do this is we wanted to be able to identify the adjacent, right? So if it has an edge, that means it's adjacent to that other vertex. So we can do 0 to 1, so we know that there's an edge from 0 to 1, 0 to 4, 1 to 3, 1 to 2, and 1 to 4. Then we also have edge from 2 to 1, 2 to 3, 4 to 1, 4 to 0, and 4 to 3. Okay. So before we start programming, we wanted to list our vertices and our edge. Then what we'll do is we would create a list of adjacency in which we can use for the matrix. Okay. So then after you have the edge, then it simply would be your list of adjacency, because if it's connected with an edge, that means that that will be adjacent. Okay, so I know that 0 is adjacent to 1, 0 is adjacent to 4, 0 is not adjacent to 3, right? It doesn't directly connect with an edge. And 0 is not adjacent to 2. Okay, so once we have the list of adjacency, then we can start building our matrix. Now, this graph is not weighted, right? We don't see any value next to the edge. Okay, in your project, right, it's weighted. It has specific miles value that's attached to each of the edge. So that way you will have to treat it as a weighted graph. On this one, it's not weighted. So we would say that each edge would be 1. Okay, and if it's not adjacent, it would be 0. So important thing to take away from this is to establish the adjacency list so we can build our matrix. Okay. Okay. So after you list your edge and your adjacency list, you can use the table to put in the values, right, for the adjacency. So our adjacent matrix, we can start with 0, 1. As we have an edge here, that will be 1. So 1 and 0 is 1. 1 and 1, we discussed this last time, it cannot connect to itself, so 0. 1 to 2, that's there, so that's a 1. 1 to 3, okay, so there's 1 to 3, 1. Let me double check that. Yep. 1 to 4, yes, we have an edge, and we listed that with the adjacency. Next, we're going to do 2. 2 to 0, none. 2 to 1, yes. 2 to 2 cannot connect to itself, so 0. 2 to 3, 1. 2 to 4, 0. Now, if you wanted to type it out in the matrix format, that's fine. Oh yeah, I forgot about that. Thank you for reminding me. I forgot about the 0. Okay, so 0 there. Okay, 0 to 4, I have 1. And then the rest is 0 to 1, I have 1, 0. Okay. So I made the adjustment for that. So if you want, you can add a row. I forgot to include 0. So 0, 0 to 0 is 0, 0 to 1, we have 1. So that's 1. 0 to 2, none. 0 to 3, none. And 0 to 4, 1. Let's verify that real quick. Yep, it's 2 degrees, so. Okay, so as you go through, check to see which vertex is adjacent to which, right? As you listed that out, that should be easy for you to plug into the matrix. So if you choose to do the course project for the solar salesman, right? So that's how you would approach it. You would start with identifying the vertex, create adjacency list, put together the matrix, put that into the documentation, and then what you will do is you can implement that on the programming side. How can you be able to show, right, that this is gonna be, these are the routes and the shortest routes is this. The cheapest route is this. Okay. So we just have to sum up the weight and then we can compare. So you have to apply condition that in that sense. So later on, you're gonna do a program with the weighted directed graph. So, so you can see how that's done. Any question? Okay. So I wanted to add this because I'm not sure how far you got in your CIS-5 class or 17A class. They kind of span across. Sometimes students, you know, they get more into more advanced topics. Sometimes students don't even get to vector. So, so I wanted to add this. So vector is an STL for C++. When you include vector, you're able to incorporate some of the built-in functionality from that library. So one of the functions that we can, the member functions that we can implement for vector is to add a new element at the end of the vector. And when you're using vector, when you do a push back, what that does is it adds that element to the end of the vector. So a vector is just a container. And vector is more dynamic than your array in such that the vector can grow and shrink depending on the number of elements inside that container. Now you can use dynamic array, of course, but you know that when you set up array, you have to, it's going to be dependent on what you state as the number of elements. So if we use a variable to represent that element, otherwise we have to use a constant. So for a vector, what we can do is we don't have to specify that to start, right? So when you look at the program, look at how they use the vector, okay? So when you add an element, you simply just use a pushback, and what it does, it drops it into the end of the vector. And what that does is it adjusts that allocated space in the memory by 1, okay? So if you have, and vector can contain lots of different things, contain all types of data. It can contain string, it can contain integers, it can contain floats, right, as in prices. So what that will do is it's going to increase that container by 1 element in size as you do 1 pushback. Okay, so it automatically reallocate the storage space, okay, if and only if the new vector size surpasses the current vector size. So it would only adjust if it needs to be bigger depending on that data type, because C++ is type heavy. So it's Java. Okay. So for C++, the way you use vectors, if you, let's say that if you plan to add more elements down the line, right? You don't want to make a huge adjustment in your program. You would start out with thinking about the container that you want to implement. And vector would be more suitable because we don't know how our data would change and, you know, how many other things that we have to add in. So in the example 1, it uses the vector. Okay. And when you look at this example, we simply just include the STL at the top. Okay. And you can just create a function for it to add in the number of elements into that vector. Okay. And that is going to, every time that you, so this function at the top, starting from line 6, it's just as the comment indicated, we would use that function to add an edge, right, by doing a push. Okay, remember V and U, okay, for our graphs. So it's going to add the edge that's going to tie that back into your vertex. Okay, because there's two things that we need to think about is what are we going to do to represent the vertex, and what are we going to do to represent the edge. So the function allows us to push in the vector, and each of the element is going to be U and V. Okay, and the way we type this is going to be integers. The second function, it simply is to use to print it. Okay. So this function here, it's going to print the content of that graph. Whatever you place in the vector, you have to iterate through each of the element to pull the information about the element so you can represent it in text, because we are not using UI. We can only use the console. So that way it needs to iterate through V to be able to give us, right, the printout. And when you see printf, you can do a cout on that. I'm sorry, I forgot to do this. But printf was commonly used in C. Okay. And so we can have it cout who is adjacent to who. Okay. So you have two functions. One is to add. Okay. One is going to be to print. And then in the main, you simply call it and pass the parameter. Okay. So here we declare int v and we would assign it 5. Okay. As you're using vector, you have to type it. Otherwise, it would not know in C++. It's type dependent. So it's going to throw an error if you don't have the proper type. Okay. And then so down here, we call on add edge, and then we simply use the parameter 0 to 1, 0 to 4, 1 to 2, 1 to 3. And so that way it will plug that in. Okay. So let me get to my repo and I run it so you can see. Sorry, I had to zoom out earlier to. So I had already explained the components of this. So when we run this, this is what you see. So it tells us that the adjacency list of vertex 0 is 1 and 4. So 0 connects to 1 and 0 connects to 4. Okay. Adjacency list for 1, 1 to 0, 1 to 2, 1 to 3, 1 to 4. Adjacency list for vertex 2, 2, 1, and 2, 3. And so forth. Okay. So even when you push those elements in, the way we control this, right? The 0, 1, 0, 4, 0, 1, and 2, that was really coming from the driver, which is the main. And this kind of, it just gives you the adjacency list at a 2D level. Any question on this? So this program simply shows you how you can use vector to build your adjacency list. Okay. Any question? Okay, no questions on the first one. Let me close this. Okay, so for after we had manually, right, look at the graph and write down our adjacency list in the matrix, we simply run our program, look at it, verify, did it match your answer, right? In part B, I think I forgot to put that there. Okay. Then once it should match, because that's the same graph is used to build the program. So if it's not, then maybe look at how you type out that program. Then I want you to look at the code, right? Look at the functions and how those functions are used to build the adjacency list. So explain to me, right, the functionality of the program, what was used to create that adjacency list. And G sounds very obvious, but I want you to think about how you would plan out writing a program like this. That's why I'm asking that question. Given a graph, can a developer create a C++ program without evaluating the adjacency of the vertices, right? So you have to look at the graph, determine it first, and then you can approach it with the programming. And in programming, we have to be methodical about how we solve a problem. Okay, many of my students, they just write program without pseudocode. You're gonna find out that, you know, that's not how you do things, because you gotta have to have an idea in your mind already on how you would approach the solution. Because if you don't plan it out accordingly, you're gonna get stuck at some point, and then you're gonna end up either editing the majority of it, right, or scrap it and then start from the beginning again. So writing a program like this, we have to methodically think about like what we have to do manually first, and then think about the components of our program and tie those components together. Questions? Okay. Oh yeah, definitely. I didn't want it to go into that because that might be because some of the students haven't taken classes that talk about linked lists. Sure, you can use linked lists, you can use deck, you can use, you know, ultimately it's, you know, it's a way that we would abstractly implement these container, right? So yes, so you can, in the later programs, you would see that it's using other than what you normally would see as an array or a vector. So you can elevate it, sure. I've had students that turn in project for this class with full data structure, you know, because they have gone through the C++ classes that give them that. I don't require it because the prerequisite for this class is just CIS-7. So, you know, yeah, you can definitely write it in a way where you would use other form of container, other like a linked list, a doubly linked list, or you know, so things like that can be implemented. And you do see example of those things online. So when you look at other example online for something similar to this, you would see it can be a longer program. Okay, so let's touch on the next part. So I wanted to touch on Struct. So when I teach CIS-17A, I try to get to like Struct and class and objects before I send them off to the next part, which is 17C or B. But just to cover the basics and making sure we're all on the same page, you would see that we can use struct in C++. Struct really represents data structure. It's a way that we can group different type of data together. Okay. So you simply just use struct and then you give it a name. And with C++, the syntax is to use a curly brace that would enclose the members that you wanted to state. And when we say members, right, they could be variables, they could be arrays. So you can state different type of members down here. Okay. So that's just a format. And then after that, you can include your object name. So an example, I took this from one of the tutorial. So you can have something like this. You have struct product. And for our product, we would have int weight, double price. Notice that there are two different types. Okay. And then after that, we can state, okay, apple, banana, melon, right, grapes, which is part of the structure known as product that we previously declared. So the data members, right, that would correlate with apple, banana, and melon in such that apple would have some form of weight and it would have some form of price. Banana would have some form of weight and price. And this is like the simplest level of how it would be applied, of course. So when you declare the struct, what you're really doing is you're creating that type, right? You're typing it as product. And in that product type, you would have members like it, which includes weight and price. And then you can use object to access, right, functions and members, or what we say methods and members inside that structure. We can put class within it. So there's many ways that we can set it up so that way it will be more organized, okay, and functional. And you wanted to use a semicolon, that's just a format for C++. And to go a little bit further, for those of you who are not familiar with class, you can have different classes. And we can use one class, right, and then another class and have some form of inheritance between the class. And so that means that one class can access property of another class or attributes in another class. So you can just create a class by naming it, give it a name, identify what it is, use a curly brace to enclose the members in your class. So in this example, it's giving you a class box. it's public, that means that other class can access its attributes. And then we would have members within that class. They are variables, length, breadth, and width. Okay. And then we can also have the functions for each class, and one class can access another class. So this gets more into the object-oriented programming side. Now, if you are private or protected, so if you don't want other class to access box class, we can make it private or we can make it protected, where it will be limited. Okay. So this kind of just gives you the background when you look at the program, right, what it entails. And if you learn Java, you started with class regardless, right? So if you understand Java, this is a breeze. Okay, so graph 2, it's a directed graph. Similar to what we've seen previously, you have 4 and 5 on their own right here. They're not connected with the rest. And then you have 0, 2, 1, and 3. And we have the arrows for the directed. So for A, we simply start with listing our vertices. So we have 0, 1, 2, 3, 4, and 5 for the vertices. Then next, what we need to do is we need to list the edges. So when you look at this graph, we know that 0 goes to 1, 1 goes to 2, 2 goes to 0, okay? So with the directed graph, this one, there's specific direction that we can establish the edges. Then after we list the edges, we would then say that here's the adjacency list. Because if it has an edge, then it would be the adjacent. So 0, 1, 1, 2, 2, 0, 2, 1, 3, 2, 4, 5, and 5, 4. Any question? Oops, sorry. Then once you have once you have the adjacency list, then you can start filling out your matrix, which I use a table. And since it's not weighted in this one, for number 2, we just use 1 if it has an edge or if it's adjacent. Okay, so I own for the 0, 0 to 0 is none, 0 to 1 is 1, and that's it, since it's directed. Then for the vertex 1, 1 to 0. So if you look at it, it doesn't go the other way, right? I cannot go from 1 to 0, so 0. Okay, 1 to 0 is 0. 1 to 1 is none. 1 to 2 is 1. It's there. Nothing at 3, nothing at 4, and nothing at 5. Then for 2, it has 2 degrees. So 2 to 0, yes. 2 to 1, yes. And the rest is none. Three to 0, 0. 3 to 1, nothing. 3 to 2, yes. We have an edge, an adjacent there, 1. And then nothing for the rest. And then for 4 and 5, so 4 goes to 5, so that's the only one. And then 5 goes to 4, that's the only one. And the rest is none. Because they are by themselves, and it's also directed. So any question with number 2, A and B? Okay. So earlier Albert asked about, can we use a linked list or, to establish a structure? Sure, right? So on this one, it's a little bit different than the other one, of course, you can see. So if you look at the comment, this structure, okay, we have a struct called node. And node, it's pointing to the next. Okay. Now with this, inside the structure, we're using val. So you have int val there. So what that's going to do is going to store the adjacency list inside each of the node, which is just the way we identified this. Okay. Then we also have another struct called edge. And here it's using source and destination. And this is important to do. So because it's directed, right? We wanted to start from one point and go to the next point. So this part mainly stored the edge. Okay. And then you have a class called graph. And remember that we made this a type. So you wanted to use that type when you create the function. Okay, just like how you use int or void, right? Or double. So with this, we write a function for the adjacency list. And we wanted to bring down that type. So our function name is get80j list node. And for the parameter, we're going to use the destination and the node head. Okay, here's the constructor, making object. Okay, So what we're doing here is we're going to say that we're going to establish the edge. Actually, I'm sorry. We're going to establish the adjacency list based on how it would connect from one node to the next. Here's the destination, and that's with the head, and that was used in the parameter. We're going to return new node from here. Then next, this end here is going to store the number of nodes in the graph, and we're going to bring that back to the main down the line. Okay, public allow us to access. So make it available so the properties can be accessed. Then next, what we're going to have is we're going to have the node that's going to point to the head. So node simply is a type that you did earlier, remember? Then we have a constructor for the array. Okay. Where is this graph coming from? That's coming from the class. So what it's saying is that this is part of that class. Okay. Then it's going to allocate the memory. Here we're using this keyword. So it's going to say this is going to be n. And since you're using pointer, you have to have no pointer. So that allows us to point to all the vertices as they are in a container. So it needs to iterate and point to each of the element in for that represents vertex. Another for loop to add all the edge to the directed graph. And when they're using unsigned like this, all that is just indicate that it's a positive value. Okay. So we start at 0. We're going to go up to the n, which shows us earlier that's the number of the edges. And we're going to iterate. We're going to increase. Okay. And with the dot source and destination, this is a way that we can access, right, the attributes from source and destination. Okay. Now, when you copy and paste your code into REPL or Visual Studio, watch out for the symbol because from Microsoft Word convert some of the symbols, and then when it goes into another application, sometimes it doesn't carry through, like curly braces, sometimes quotation marks, stuff like that. So if it throws an error, just check your syntax. But I try to copy and paste the code so you don't have to type it out. It's lengthy. And I kept it one color because Canvas actually ding me if it's red. Anyway, so at this point, it's going to point to, this is your head pointer for the node. Now with C++, all of these are commented out. You don't have to uncomment them. That's just showing you how you can, you can uncomment for the undirected graph. But I think you have to modify some things, otherwise it might throw an error. So if you have a constructor you have to deconstruct in C++, you have to get rid of it. Otherwise that thing stays there forever. And a constructor, what it is just a blueprint, right, of class. And so that way you can blueprint back to, for inheritance reason, for access, for property access reasons. So once we're done, we have to deconstruct it. We have to get rid of it. Otherwise, it just occupies storage allocation. And then here is the print. So this function is just mainly for displaying. So in the main, what we do is we have to tie everything together. We got to state what our edges, where it's coming from, X to Y, source to destination, right? So we declare the type edge and a container that stores our XY value or source destination value. Then we specify the number of vertices we're using. This is just to specify the calculate the number of edges. Call on the graph function in the graph type. So that way we can construct the graph. Then this iterates for the print. And then call on the print, the void print that we had earlier, the print list. Okay, so run. And so there you have it. This is the way that we can represent it in programming for that directed graph. Something can be that simple and it would take over 100 lines to, maybe less without the comment. Okay, so I want to show you how that can be done. This is a little bit more advanced than your normal everything run in the main and a couple of the functions. So if you implement data structure, it's, it's better. Okay. So once you have the program inputted and ran, I want you to look at it and then answer the questions. Do your best. Okay. And I left a comment there for you to look at so that way it kind of help you if you're not familiar with using class or struct. Okay, so look at the program, look at the graph first. So look at graph 2. Determine the areas of the program that would represent the graph component, vertices, edges, and adjacency. Okay. Compare the program adjacency list with the result that you got from part B from earlier. Is it matching? Can a developer create this program without predetermining the adjacency list? Should be an obvious answer. Now compare exercise 2 to the exercise 1. Right? Or look at the so it says compare the simple graph program, which is exercise 1. I should state that. What areas of the program produce the edge direction? What's the difference between the previous one and this one? How can we tell which is going into which vertex is pointing to which one, right? So in this one, we have to use pointer and we have to specify which one is the source and which one is the destination, right? Look at this on how under the class graph on how that was used. How is it pointing to the next node from the current node and how it builds the adjacency. Okay. So explain the code functionality in the overall program. Okay, any question as far as number 2? No question. Okay, so make sure that we include the answers for these in our document that we're going to turn in. All right, let's work on number 3. So similar to number 2, the graph looks the same, but now we add in the weight. Okay. So for number 3, we're working directed weighted graph. So when we build our matrix, we have to include the weight for each of the edge. So again, since it's the same, you can bring down the answer for part A from number 2, or you can retype it. So we would start with number 3A by listing our vertices. 0, 1, 2, 3, 4, 5. After that, we would list the edges. 0 to 1, 1 to 2, 2 to 0, 2 to 1, 3 to 2, 4 to 5, and 5 to 4. Questions? Okay, very easy. Part A of number 3. Let me move this up. I recopied the picture, so. All right. For B, we simply just use the graph and list our adjacency. So if you have the edge, then you can just use the same for adjacency. Just use the parentheses instead of the curly brace. So we have 0, 1, 1, 2, 2, 0, 2, 1, 3, 2, 4, 5, and 5, 4. Now, unlike the other one, when you put in the table or you're using your matrix, you have to make sure that you include the edge value. So for 0 to 0, I put 0. 0 to 1, it's 6, so I put 6. 0 to 2, nothing, nothing on 3, nothing on 4, and nothing on 5, because 0 only have 1 degree. 0 to, 1 to 0, nothing. 1 to 1, nothing. 1 to 2, I have 7. So when it goes from 1 to 2, it's 7. So put 7. And the rest is nothing, because 1 also have 1 degree. Two to 0, we have 5. 2 to 0 is 5. 2 to 1 is 4. 2 to 2, nothing, nothing, and nothing, and nothing there. Okay. So for 3, it's only adjacent to 2, that's 10. 3 to 2 is 10. And for 4, 4 is adjacent to 5, and that's 3. And 5 is adjacent to 4 and weighted 1. So Okay. Any question? Says what Albert asks, what would be the reason of having weighted value if the vertex only points to another vertex? In some cases, that weighted value can be a priority value. And in other cases, so, it's a way that we can differentiate one node with the next, or that edge, I should say, that edge or certain path with another path. Okay, so for example, if you're looking at 3 and 2, in this case, right? So if we're saying this is high priority comparing to all the other, let's say that in an example, if we say that all of these are database servers, okay? And the central office is 3. And this is when let's say we have to run a batch file that syncs data or sets up the data, then we would have, this is going to be the highest priority, this edge. So what that means is we're going to do from 3 to 2 first, right? And then 2 is going to sync with this one because it has the higher value here at 5. Then when it's going to 1. Okay. So sometime that they would have it weighted for specific reasons, and that value can represent something in a certain scale. Now, if you have this as 10, and if all of them are the same way, what will happen is then we can, in the instructions for the system, we can say that it can choose either one. So we can sync 2 to this one, 2 to 1, vice versa. Okay, so there's no priority in that sense. Okay, and you would see this more in like setting up communication system, routing, syncing data, communication, and so forth. Now, if we don't put the weight here, right, then we can't really instruct the system to really look at what would be the high priority across. And that could also represent miles, resource utilization, stick scale, could be various things. Okay. Other questions? Okay, so let's talk about the last one, and then we should have ample time for other form of questions in case you have questions with lab or project. Okay. So as you look at this program, it looks very familiar to you because you did one just like it, right? With small modification, that is. Okay, so we see pretty much the same as number 2, but there's an area that was added. You got the weight added, and it was, if you add it there, you're going to make sure that you have it in the parameter. And so there's a third element that we have to add it to really include weight, right? Like we would have a variable to store what that is. Okay, a value for that. Okay, so we have weight added there, weight added to our adjacency list because that would generate the matrix, and then for our nodes. Okay, so pretty much the same throughout except for that third thing. So in the edges for the weighted graph, we wanted to also represent what that weight is for each of the edge as it iterates through, right, with the for loop here. Okay, which is the source going to destination, and that edge is weighted. So we wanted to show the weight there. And then it would insert it with the into the adjacency list, and so therefore we also need to have that there. Then simply deconstruct. For our print, we also wanted to have a pointer to the cost. Then one of the major area that's also modified compared to example 2 is that we have a W here. So before we have the X and the Y to show which vertex to which vertex, and now we wanted to have a third component which is going to represent the weight for each of these. Okay, so that's going to show under the decoration and the assignment for edges. Okay, then the rest we simply print. So here we go. So when it prints this, it simply give you, right, one vertex to another vertex and the weight of that, one vertex to another vertex, the weight, and so forth. So a group of 3. And that's how we can represent adjacency with directed weight graph. Okay, any question? So look at the program output and also question B, number 3, to see if it matches up to what you had. Okay. And then again, we need to answer E. Can we create this program without knowing the adjacency matrix or the list? We want to compare this to exercise 2 and identify the example 3 program that produced the weighted edge. So find the section of the program that would tell you what the weight it would be. And I pointed it out just now, right? You would start at the top and you would look at how that was implemented. It started with here and then it goes down to different section where we would be able to tie that back to the edge. And then here and so on. Okay, explain the functionality of those areas and how that program can produce a directed weighted graph. Okay, any question? Okay, so this kind of give you an overview of you know, if you choose number one, what is expected, right? There is more to that course project number one than just printing out the matrix. That's only one component. You have to put in the conditional statement to select, right, the path that's going to be the shortest or the cheapest. Okay. So you have to strategize on how to be able to come up with that. And last semester and the semester before, somebody turned in programs like that for that particular case that was very good. Okay. And I do test every single program that's submitted. And I look at your code. So for the project, and then I use the rubric to actually grade it. Okay. Now, unlike last semester, I will require everybody to turn in the project, even if you work in team, because it took me a very long time to link people with teams. And then when I commented on the project, I have to duplicate the comment. So it ended up like mismatching. And so I wanted to make sure that you can see your project, even though you work in team, and you can see the comments so you can get the proper feedback and, you know, how you can improve your project over time. Okay, so it shouldn't stop here in this class because it's a course project. If you enjoy it, if you write a really good blackjack game, then take it and improve it, put UI on it, to bring it to the next level, and then be able to showcase yourself with employers. And that's the whole point. Okay, any question? Okay, so as we have a little bit of time left, I want to touch back on this so I can explain this a little bit more on the expectations. Okay, so I already talked about the project sign up. Okay, and this is not due until November 12th. So you do have a little bit of time to think it over and what you want to do. Okay, do a little bit of research, and once you go through certain chapter, the popular one has always been the Vigineer. There's a lot of Vigineer example program in different programming languages available. But I do have a software that I check so I can find if you did copy and paste someone. Okay. Now you can take a look at the example online and see how you can approach it and do better. Of course, that's totally understandable. Okay. So think about what you want to do and then sign up. Then for the next part, which is part 2. So what are you submitting for this one? You will need to give me a CPP. Now, if you are writing a file or you're using, you know, some form of module or something like that, I need to have all the files, because if I run it and if it doesn't work, I just assume that it doesn't work. So if you have all the components for your project, right, make sure that you zip it and upload it. Okay. So you need to submit a document that contain your project description, and you can use the template, this one, okay, documentation guide. Answer the questions on that document. Okay, let me open it and show you. Oh, not that one. Okay. So if you're working by yourself, just put your, you know, your name, and if you decide to have a project team name for your own, for yourself, that's fine too, like your own company, whatever you like. Okay. I want the details about your project. What are you trying to solve? What solution have you implemented? Like the algorithm that you use, or how did you approach it? Okay, you can, all of this can be all like at least a single page, double space. I'm not fancy. I don't need title page. I don't need, you know, there are certain class that I require certain format, but for this one, I'm pretty open. So just go through and answer the questions. Instead of copy and paste the question, put it in sections and make it look nice. So think of it like writing an executive summary for this, for your project. Okay. Explain your calculations and your algorithm, especially if you're working with probability, if you're looking at graphs, how do you determine, put in your matrix, put in your adjacency list, right? If you're doing the blackjack ones, state the probability, right? You can give me some example for certain scenario, how you handle the program, what kind of, you know, objective are you achieving? Okay. So what is the objective of your program? So look at the project criteria and state that, right? What are you trying to achieve? Explain how your program is interacting with the user and its purpose. Okay. And then how is discrete structure implemented with your program? No program is perfect, right? It's a process for us to be better, to improve technology, software, etc. So think about the limitations of your program. And I test it to the limit too. Sometime I would, you know, especially all of these programs should take some kind of input. And so I would test it to see if your conditions, there's some exception that we would come across. And if you already learn how to handle exception, you can also implement that too. That will give it. Now, if it's not, right, expect some limitations and note it. And then for the next person that would look at your project and take your project and improve it, what do you recommend? How can they make it better? Okay. How can they make it more functional, more efficient? You know, so there's a lot of different aspects that we can look at for improvement in that area. I'm expecting a flow chart and a pseudocode. So I know that CIS-7 addressed this, right? But some faculty would do better on this than others. Okay, so if you need help with this, see me or communicate with me. I'll point you to the resources. Now, the things that I have, my biggest pet peeve is when I look at a really, well, not shouldn't say really good, a flow chart, then there's no branches, right? Like somebody just threw it together or a team member just put together without even looking at the program that the other person wrote. Okay. So make sure that you communicate and there's no branching, there's no relevant, you know, variables, functions stated, etc. Okay. So I'm gonna look for those things. And so that's why I stated down here. It needs to have a flow from start to finish. So in your pseudocode, any operation you have, you need to include that. Okay. Like, you know, if you use it, if you defining functions, you want to state the functions, and then you want, when you call that functions, you need to come back to it. Okay. So be sure to include all the decision making branching. Okay. So you can use your standard shape and flow chart. I'm not too picky about this one. I've seen people turn in stuff that's not standard. There are many online drawing tools you can use for flowchart. Draw.io is a free tool. Then you can save it on the cloud and you can export it out as a PDF and you can link it all together in your document. That's fine. And then if you're using Microsoft Office, like Microsoft Word, that's probably at the basis using shape, but it's very tedious. So there is online tool. I recommend you use it so you can have it for the future. Okay. But if you put it in a Word document, yes, you can use shape and then insert text, but that will be very manual. Okay. So this is part 1. Or I'm sorry. Yeah, that's part 1. and or part two. Part two, CPP and documentation. Okay, altogether 200 points. So when I grade this, I go through the rubric. Okay, I wanted to assess based on if you apply the concept in your programming or discrete structure, if you're able to explain your solutions and approaches in the documentation on both sides, like applying the math, applying the discrete, right? How you able to bring in the programming explanation. And then there's a 40 points that's dedicated to teamwork, or in the case, if you are able to manage your project, if you do it individually. So if you turn in something that's incomplete, right, some of those points will be omitted because simply it just shows that you can't manage your task. And I will share with you some of the things that you can do to keep track of your tasks and just to keep yourself on track for the project in the upcoming week. Okay. I'm gonna finish this one and I will repost the part 3. I have to add some of the resources in here, so part 3 is not ready until probably next week. Okay. Do you have any questions? Okay. It might sound very crazy hard right now, but once you can see some example, once you have a better understanding of some of the other options, it's gonna be easier. Okay. And some of my former students, they love this. They enjoy doing it at the end, and you learn a lot by doing project. I'm one of the faculty that's really pro project based learning, because I can tell you a lot of things, I can say a lot of things in class, I can make you read a lot of things, but it doesn't stick until you do it. So this is my way of making sure that you have something viable to show potential employers and people that you can do this. Okay. All right. If with no further questions, you can type in your name in the chat, and you can stick around and ask questions if you like. And hope you have a wonderful weekend. It's warming up, and I will see you next week. Have a wonderful evening. And Braxton, I sent something to your email. You won the quizzes game, so you should check your email if you haven't done that. Okay. I'll stick around for questions if you need my help.